Hello everyone, welcome back to Codzilla. Today we are again back with another problem solving question. So let's start off with today's question. Today's question is more of a direct way in which we can solve it off. Although there is another thing which I will be telling you at the end of this video, another method, or I can say another point which you can consider when this problem comes in front of you, and you can tell this to your interviewer or wherever you are trying to solve this specific problem. So today's problem will be on LeetCode. So now let's go to LeetCode and see what is the problem actually. So this is the problem statement which we have got. The problem statement is named as majority element. Now firstly, doing it in our traditional way and our OneNote so that we can quickly analyze what is written in the question or what does this question want from us. So it is given that an array will be given to us, a nums array will be given to us which have size of n, return the majority element. Now it might you might think the majority element means the element which has appeared maximum time, but although it is not a question which is related to peak element. It is not a question which is related to peak element. The question related to peak element will be coming in the upcoming videos, but this one is not a peak element question. It is a majority element question. So we have to figure out what is a majority element. So it is written in the question only. The majority element is the element that has appeared more than n by 2th times. Now what does n here is? N means number of terms in that array, size of array, number of terms divided by 2. Then if a number has appeared more than this much, then it is the majority element in that array. So that's all we have to find out. We have to find a number which has appeared more than half of the size of that array. And what they have written is, you may assume that majority element always exists in an array. So they have also written majority element will always exist. So we went out of some of the corner cases which we have, like but if we didn't have majority element but we have it as less than something, there will be a majority element, that is for sure. Now in this case you can see 3 to 3. So if I will do n by 2, n means size of an array. So nums dot size, uh, it will be easy for us. Nums dot size will give us size of array, and n by 2 will give us around 3 by 2, and 3 by 2 will be equals to 1.5. Okay, so what we can consider from here is 1.5. We have to get any of the number which has appeared more than 1.5. 1.5 is not possible. So although we want the greater only, it means we want greater than 1.5. It can be 2, it can be 3, it can be 4, it can be anything, but it should be just greater than 1.5, and that is 2. And 3 has appeared 2 times, so that's why 3 will be our answer. Similarly here, if I will write 2, 2, 1, 1, 1, 2, 2. Now in this problem statement, 1 has appeared in total 3 times, whereas 2 has appeared in total 4 times. And the length of this array is n equals to 7. So by the formula, we need a number, majority element will be that number which has appeared more than 7 by 2 times. It will be 3.5. So now 3 is lesser than 3.5, so we can't consider it. That's why the 4 will be considered as the majority element, and the number which has appeared 4 times, obviously 2, which we got as an answer. So I think the problem statement is pretty much clear, like how we will be, what we want to give to them, and what is the majority element. Now let's uh, think on the logic, which is the main heart of every problem solving uh, question. So now logic, what we can do, just think about it. If we have a array, if we have a, if first of all we find the, we will find what is n by 2 of we'll find n by 2x. So this will be a threshold, we can say. Threshold means just a value. Once any of the elements count exceeds this, we will be returning it as a majority element. So this will be our, like we can say, a value. After crossing this value, every element will be like after crossing the count of this much value, we can consider it is as a majority element. Second step will be, what if I will sort my array? Just think about it. If I will sort the array, then what will happen in this case? If because I have to find the count here, I can like visually see it. One has appeared three times, two has appeared two times, then again two has appeared two times. So can I do it in something like, if 2 2 1 1 1 2 2 is given to us, if I will sort it, then it will be like 1 1 1 2 2 2 2. So in this case, what can I do is I can start the count of it. So how can I start the count of it? It generally means, if I will encounter any of the number which is similar to the upcoming number, then I will increase the count. Okay. If it is again equal, the count will again get increased. So initially count will be 1, because every number which will be appearing, count will be 1 for that. Next number, count become 2. Next number also same, count becomes 3. And then in the case, in the case, along with these counts, what I will be doing is, I will be also applying a check. If if our count has reached, if our count has reached greater than that n by 2th number, in that case, if it has reached, then I will just return that that number. I will just return nums I, because the reason is, majority element is the element which has appeared more than n by 2 times. We didn't need to think how many times it has appeared. Once we got a number which has appeared more than n by 2 times, return it as a majority element and move on. Now, next, when a new number comes in front of us, that is 2. In that case, first of all, we will be writing a else condition. We will be writing an else condition in which what will happen? Firstly, it will compare, are these both numbers equal? We will say no, so it will go into the else condition, and in else I will just reinitialize my count to 1, so that I can start counting of twos also. Then again in the loop, when another 2 will come, then it will compare with these two numbers. Are they equal? Yes, they are. Increase count. Check if it is greater than n by 2. It is not. Then go again. Check, check, and once it reached, I will be returning nums of I. Although there might be one case also, uh, like we have to write a base case or something we have to return. So for that it will be ARR of 0 or nums of 0. Like the first value we have to return as a majority element if we didn't able to pass any of the elements as our case. So that's all what we have to do. The logic we have thought of that might work. Let's see if it works or not. So now let's get started. So this is the LeetCode compiler. Uh, you should get habitual of coding in these competitive compilers. So now let's get started. So firstly, going with the step number 1, which we have written, find the n by 2x. So let me write it as x. X is equals to nums dot size, and this 2 is divided by 2. Okay. Then a count which I needed, which will be initially 1, count variable just to count the consecutive elements, or the element which has appeared, the count of the element. Now third step, what is the third step I have written? It is to sort the array. So the thing which we have got in the competitive compiler, that happens a lot. Like if you get a vector int, you might get confused. Okay, this is vector int, I can't solve it. But think of vector int just as an array. Okay, we will be all the figuring out what is the vector, what is the int written here, what is the and which is written after that, and what are all these things. But for the questions, you can start off just thinking it as an array. Now, first of all, we have to sort. So for sorting the vector which we have, we have to give it like nums dot begin and nums dot end. For the arrays, it is bit different because in the arrays we have to give about like ARR and then ARR plus size. So sorting is also done. Now let's figure out what is the next step. Now we have to iterate in this. So for iteration, let's make a for loop from int I equals to 0 and it will be going till I less than nums dot size and then I plus plus just incrementing the value. Now in this loop, let's figure out what is the condition which we have to write because we want the next number to be equal to the previous number. Now if I will write a if condition, if our nums ith index means the starting one is equals to the nums I plus 1th index, in that case, what will happen? We have to increment the count. Doing the first step, incrementing the count. Next one is if our count reaches somehow greater than the x, then x is the value of that n by 2 majority element. Return, in that case, we have to return the value. So just write return nums I. So this is the majority element. Also, in else condition, we have to write if our nums I and nums I plus 1 is not equal. In that case, just reinitialize the count equals to 1 so that we can start counting off the new numbers which we have. And that's all. I think in the last we can just do one more thing, that is to just return nums I, or I can say nums 0 means the first element which we have. And that's all, I think so. We might have got the solution for this. Now, I have seen a edge case in this. So, can you see a edge case or a thing which can cause a problem in front of you? It will be in the front, in the code which is written in front of you. I will run the test cases. I knew that it will not, it might run for some of the test cases, but if I submit it, I will get for sure an error and I knew how to fix it, but you need to figure out what can be the edge case here. So firstly, let's run this and see if it works or not. If it doesn't work, then it is of no use case. It got accepted here. You might be thinking, okay, it will work, it will work. And in the question, if you have something like you can see two test cases and other are not visible, then you will not again figure out the question. So that is the thing. Once after you are done with solving a problem, after that, just go back and see it once. Is it have any of the edge cases or something you have missed? Because the visible test cases might run, but for the edge cases or something else, or the bigger test cases, you might fail. Now, if I submit this, I will for sure get failed in this due to runtime error or something. A runtime error in front of you. Yeah. Now, what can be the runtime error? Let's see. So that's all what you will be getting. Now, what if I say what I am doing is I am starting from nums I, which is in bond, but I am going till nums I plus 1. So nums I plus 1. So if just suppose my I reaches at the lastmost index of an array, in that case, what will happen? My I plus 1 will be out of the bond. Just suppose my I will go from 0 and go till nums dot size. So nums dot size means the last element of the array. So nums I will be the last element and nums I plus 1 will be the element which will be out of bound and that will cause runtime error. Now if I will write minus 1 so that it will remain inside its bound, then it might get passed. Let's see if it is or it is not. Let's run this, check if it works or not. Yeah, it got accepted. It got accepted. So that's how it works. That's how we can figure out the majority element in an array. Okay, so I think we are done with this problem. Now, this is the basic approach which you can solve off. But more you will do problem solving, more shortcuts you can get. But that shortcuts are not like just writing or just using something and finding out the answer. This is just like a legit logic which you can thought of while solving the problem. Let me explain one of them in the one note only. Let's do it. If I have a number, let's take this one only, 2211, 2222, 111, 2, 2. Now the thing is, n by it should majority element is the element which has appeared more than n by 2. It should have appeared, sorry, it should have appeared more than n by 2. And what is n by 2? Half of size, half of the size. Now what does this mean is, what does this mean is that our half of our array, that half portion of our array will be of same element, will be of same element. Okay. So if in a case, if we have element which is like x, 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 so 1, 2, 3, 4, 5, 6, 7, 8. 8 elements are in front of us. Let's take one more also, 9 elements. In this case, n by 2s, n by 2s means 9 by 2, and 9 by 2 eventually means 4.5. So majority element should have appeared 5 times in order to be our answer. Now just suppose, and what we do in this array, we do a sort. We apply a sort, and then this is our array which we have got. Now we want an element which has appeared 5 times. Now just think about it. Element starts from here. Just suppose if it is the 0 or if it is in -1, and due to the sorting it came in the beginning. Then 1, 2, 3, 4, 5. So these 5 elements. Okay. Again, let's do one more time. If that element, if we have one element which is smaller than those continuous elements, majority element also. Let's suppose this was that element. So we start off with here. Okay, this goes till here. The 5 elements, because we have sorted. For this, it will go till here. For this, it will go till here. And for this, it is the last one which will go till the end. So 1, 2, 3, 4, 5. So this is the most possible one. Like we can have a RMS element because of the sorting which have came to the beginning. We have an element which can start off with the first, second, third, fourth till fifth. Okay, but from here it is not possible eventually, because we want an element which should have appeared more than 4.5, means which should have appeared at least 5 times. And here, if we start from here, it will be like 1, 2, 3. So in total, 4 elements will be there, and we can't get the 5 elements or the majority element. So from here, what you can see is, just think about this term which we have. So this term is actually the term which has appeared most of the time, or I can say all of the times. When we take this one, then also this was here. When we take this was also here. When we appeared here, then also it was in the range. When we took this, then also it was in the range. When we took this only, then also it was in the range. What does this mean is, I can actually take this whole thing off, and just return nums nums x, and I didn't need account to. It got accepted. Yeah. So that was the logic which I was telling about. If I will submit it, let's try to submit this and see if it works or not. It got submitted also. So that is the logic which I was telling. If a number which has appeared more than, if we have a number which has appeared more than n by 2th times, then it means it will occupy that much space. It will occupy that much space so that it will eventually be in the middle. The number we have to return, if even if we take it, it is in the centermost, and it starts from the beginning only, then it will take more than half of the space because we need a number which has appeared more than n by 2th time. So it will be like even if we start from the beginning, the first most element because of the sorting is our that number that is majority element, then it will take space more than n by 2. And what happens is n by 2, we have to find element which has appeared more than half. Okay, so it would have appeared more than half, and n by 2, if we take, so it will be just for if it is 7.5, it gives us answer as 7.5. Okay, then in that case, we will be taking 7 as the ARR because we are also finding nums n by 2. So if our n is 9 just suppose, then 9 by 2 will be 4.5. So it will be giving us number at 4 because it takes a floor value. So that's how it all works. So the number which is a majority element, it will be for sure at the middle because what happens is half of the array will be taken by him. That's why it is the majority, and that's how we can find an alternative way, or we can say another way in which you can solve this problem in way more optimized way. Although you can tell the intuition or you can tell the logic, okay, in this way we can find the majority element. Okay, but if interviewer asks you to optimize it, then this will be the most optimized one. And if you see the time complexity, it will be n log n, which is the time complexity of using the sorting algorithm. So that's how it works, and that's how you can find out the solution. So that's all for the video. I hope you liked it. That's how we can solve up this problem. I can remove these sections and then just go on with just another submission and then re-verify it to you like we didn't did anything else out of the box. It is just a simple solution of finding the majority elements with a shortcut, we can say, or a bit more logical building. That's all for the video. I hope you liked it and I hope you will solve it also. So that's all. I hope you liked it. Thanks for watching. Bye bye.